When you look at a pressure vessel, you can see a big cylinder. That cylinder is not only the part of pressure vessel. There are many other components in a pressure vessel. If you are starting your career in static equipment engineer, this video will help you to identify what are all the particular components of the pressure vessel and what are all the uses of those parts, where we are going to use those parts, and we will break each and every components in this video. So keep watching the video. Pressure vessel components. Why we have to learn about the components? Vessel consists of multiple distinct fabrication parts, right? It is not only the shell and head. Each part serves a unique mechanical and process purposes. Proper understanding is critical for safer design, and we need to know about the foundation of the pressure vessel. We need to know about how to read a drawing, how to understand a pressure vessel. For understanding the pressure vessel, we need to know the exact components of the pressure vessel. In this slide, you can able to see the complete assembly of the pressure vessel. Here you can able to see the shells, heads, nozzles, flanges, saddle support, name plate, gaskets. It will be available on the flanges. I have marked it wrongly, ignore it. And lifting lugs, internal and external stiffening rings, and anchoring bolts. In further slides, we can able to see each and every components in detail. The first one is shell. Shell is the primary body. As you know, the main pressure containing enclosure. Actually, shell is the main pressure containing enclosure. You can able to see almost 90% of the pressure vessel is occupied by the shell comparing to descent or any other parts. If you see about the geometry, the shells are usually cylindrical. Sometimes it will be spherical also. You can able to see the spherical pressure vessels in the LNG and any other process plants. Thickness is dedicated strictly by internal and external pressures. Sometimes the external loads also will govern the thickness. And fabrication. Mostly the shell is fabricated using flat plates. You can able to see here, it is a weld joint. It's a flat plate. It is rolled and welded together to form a cylinder. The heads. There are different types of heads. If you saw my previous video, you can able to identify what are the different kinds of heads, but I will brief you here. We have hemispherical heads, we have 2:1 ellipsoidal heads, we have toruspherical heads, we have flattens. The hemispherical heads are highest strength and highest fabrication cost. The fabrication of this hemispherical head is really a complicated one. Normally most of the fabricators won't do this kind of fabrication. 2:1 ellipsoidal head, it is industrial standard. You can able to see this kind of dish everywhere, almost everywhere in every industry. You can able to see these kind of dishes. Normally this ellipsoidal head are used to maintain the cost and also the strength in balance. And toruspherical heads, almost you can able to see these two are same, but it is not same. It is a perfect elliptical one, but it is not a perfect elliptical. It is bit different comparing to the elliptical. Also this toruspherical is not as strong as this ellipsoidal, little bit weaker comparing to this ellipsoidal, and also the forming cost is low comparing to this ellipsoidal. Finally the flatheads. Flatheads, as you know, the flatheads are very weakest comparing to all these heads, and it is directly proportional to the thickness. If we have a weak design, the thickness will be increased. If the thickness will be increased, the cost of the material will going to be increased. Normally we will use this type of flatheads in the heat exchangers. And nozzles and its connection. Actually this topic itself is a big topic. Particular topic itself requires a separate video. I will try to create a separate video for this nozzles and connections, but here I briefly explain about nozzle and its connections. In a pressure vessel, we can use a nozzle as a process flow, utility, instrumentation, and for safety purpose also. In the process flow, we normally use it as inlet and outlet connections for the fluids, and for utility, common as vent in the top and drains in the bottom. Instrumentation, it is normally used to connect as the pressure gauges and temperature gauges, and for safety, it is mostly related to the pressure relief valves and rupture discs. And flanges. Purpose of the flanges is to provide a bolted and separatable connection to the plant piping. Normally, a vessel is designed for nozzles, right? So we need a process connections to be come inside the vessel, and it has to be carried out via a pipe. For those connections, we can't able to build a pipe directly on the pressure vessels and transport to the particular site, and we will use it for sealing, Use a compressed gasket between phases to prevent the leakage. For maintenance, crucial for removing valves or modifying the lines without cutting a steel. A vessel must have a end connection, right? A vessel cannot be linked with all the pipings. It must have a end connection. The end connection is the flange. Some places we also use the butt welding also. We will directly weld the piping with our nozzles, but most of the places we use the nozzles. The nozzles are very easy to remove and also assemble. If there is any maintenance work, if there is any pigging or any other steaming or steam out, it is very easy to remove the vessel and do the maintenance. The flanges are connected using fasteners. Here you can able to see. If we remove the nut, we can able to separate this part and this part separately. So it is very easy to maintain, and it is also very easy to install a particular vessel on a site. Also, there are different types of flanges like belt neck flanges, slip-on flanges, blind flanges, and also we have flanges like long belt neck flange, threaded flange, and socket flange. One bonus point I will give: these flanges are not only used in the pipelines or in the nozzles, it is also used in the vessel to vessel connection. You consider this pipeline as a vessel, we can able to join a shell using a flange connections. That is mostly used for easy maintenance purposes, and also if there is any special applications like filter applications, separation applications, for those kind of applications we use this girth flange. It is not a standard flange, we have to design our own flange. It is available in Appendix 2. Supports: if there is a pressure vessel, it has to be supported, right? It has to be supported either in the way of skirt, in the way of saddle, in the way of leg, in the way of lug. We need at least one of this support to support our pressure vessel. If it is a tall vertical column or reactor, we use the skirt support. If it is a horizontal vessel or any heat exchanger, we use the saddle support. If the vessel is small vertical vessel and also it is located outside the plant, if the vessel is not available inside a indoor facility, we will go for lug support. And also for spears, mostly for spherical vessels, we go for the leg support with bracing. And lug supports. Lug supports are also called as the brackets. It is normally used to hang the vessel through steel platforms. These kinds of supports are normally used in the indoor facility. If the vessel is located inside an indoor facility, most of the times it will be a lug supported, because for the easy access and for the easy maintenance we use this kind of lug supports. Access components. We have access components as manway. It's usually 500 NB. It's more than 500 NB sometimes. And handholds. If the vessel is smaller vessel, if it is a 1 kL vessel, 1 kL means 1 kiloliters vessel, we can't able to give manway in the smaller vessel, because the vessel itself you consider a dia as 1000 mm and we have nozzle of 20 inch. That means 500 NB nozzles in a 1000 mm vessel is not at all acceptable. And also we have some restrictions from ASME. That's why we will avoid the manway and we will go for the handholds for the smaller vessels. Davitom is kind of a crane. It is used to lift the heavy manway blind flanges. During the maintenance time, there are 2 or more labors will require to lift the manway flange. To avoid those labors, we will provide the Davitom for the easy access and easy opening. In most of the pressure vessel, it is not common to use ladder or any platform, but we have ladders and platforms for bigger vessels, which is directly attached to the pressure vessel. If we need to access the manway in the top of the dish, we need to climb to the top of the pressure vessel. For those purposes, we use the ladders. And also for the large storage vessels, you can able to see staircase also. It might be a spherical staircase or zigzag staircase, and platforms. Most of the horizontal vessels have platforms, because the manway will be available on the top of the horizontal pressure vessel. To access the manway and to enter inside the vessel, we have to be in the top of the vessel, right? We can't able to stand on the pressure vessel. Hence, you know, the pressure vessel is on round shape or in cylindrical shape. We can't able to stand on the top of the pressure vessel. We will provide a safety platform which will be supported on the vessel. Safety components. Here we have pressure relief valve, rupture disc, earthing lugs, nameplates. We have some other also, but I have listed a major components. Pressure relief valve. Actually, pressure relief valve is used to automatically open if internal pressure exceeds the safer limits. You know the operation of the pressure relief valve, right? If a vessel can withstand maximum 10 bar, the pressure relief valve will be set at 9 or 8 bars. The pressure relief valve is kind of working like our pressure cooker whistle. That and rupture disc. For rupture disc also, I will take the example as the pressure cooker lid. In the pressure cooker lid, we have whistle, and the side you can able to see a small valve kind of thing. Actually, that is the rupture disc. If the pressure relief valve fails, that means the whistle fails, then the rupture disc will burst and it will release the pressure without bursting the whole pressure cooker. That is the purpose of this rupture disc, earthing lugs. Earthing lugs are commonly used to avoid the sparks. Everywhere there will be a static electricity, right? To avoid the static electricity spark, we will use the earthing lugs. Nameplate. Actually, this is the nameplate. You can able to see here. Nameplate is the ID card of the pressure vessel. It shows the ASME stamping, and it will shows each and every detail of the particular pressure vessel. It will show the MAWP, it will show the design pressure, it will show the capacity of the pressure vessel, it will show who manufactured the pressure vessel. Every detail will be available on the nameplates. Additional components. These components are might be there and might not be there for the pressure vessels. Lifting lugs and trunnions. You already know what is lifting lug and trunnion are almost similar to the lifting lugs, but it will be available on the shells. The main purpose of the trunnion is to lift the vessel from horizontal to vertical position. Stiffening rings, you already know, it is welded around the shell or welded inside the shell to prevent the collapse under the vacuum pressure. Beer plate and impingement plate. These plates are used to protect the internal shell wall from high velocity fluid erosion. And the beer plate is also similar, but impingement plate's size is very small. Beer plate will be larger comparing to the impingement plate. Internal baffles. So if you want to separate a vessel into two different parts, we use a baffle as a separator. And internals, we have internals like baffles, we have trays, packing, demister pad plates. For tall columns we have trays, and also we have demister pads to separate the moisture. Agitators, actually it is mostly available on the reactors and the mixers. Agitator is used to mix 2 or 3 different fluids inside a particular vessel. Here you can able to see the agitator shaft and blades. Demister tray will be available on the top of the vessel. It will be mostly used to remove the moisture from the steam. From this video you can able to know that actually each and every component is very important. Why every component is matter? It is pressure containment, structural integrity and safe operation. To ensure all these things, every component is matter. We have to design each and every component very carefully. We can able to separate this design into 2 different parts. One is pressure parts and one is non-pressure parts. Mostly the pressure parts will be shell, heads, nozzles, flanges. These are all come under pressure parts. For non-pressure parts like supports, lifting lugs, baffles, those are all non-pressure parts. For pressure parts we can able to design using ASME section 8 division 1, but for non-pressure parts we can't able to design using ASME section 8 division 1. We have to design the non-pressure parts using handbook or any other different codes. We can't able to design using ASME section 8 division 1. Final takeaway, we understand the precise purpose of each and every individual components. We discuss about the shell, heads, nozzles, supports from the structural baseline, and also we understand the components must work perfectly together to ensure the safety. ASME specifies exactly how each part is designed and fabricated, and also ASME specifies exactly how each part is designed and fabricated. I hope you have got a good knowledge in this video. You know about the pressure vessel components, what are the components we are using for a pressure vessel, how we are going to design those components in the pressure vessel. Those things also we have discussed. So it will be a very good video for you. Okay, I will see you in the next video. Until then, tada, bye bye.